There was a recent study done on topics discussed in the management literature, and change came out way on top. The problem of management of change has become the central focus of most management philosophers, teachers, and practitioners in the field. And it's an interesting literature to examine because of something that's missing from it. Ever since the work of Toffler in '71 on future shock, we've all been aware that one of the central problems of our time is coping with accelerating rate of change. It's the inability to cope with such change that Toffler calls future shock. But in that literature, the nature of the problem is identified exclusively in terms of the rate of change. No reference is made to the content of it. Now, the students at the university who are forced to go through that literature in some detail invariably come up with the observation that even if it is true that one need not understand what is changing in order to understand the nature of the problem, it may not be true that you can get away without understanding the nature of change to find out what to do about it. And so they repeatedly ask, is there any way that we can get some kind of comprehensive understanding of what the nature of the change is, which gives us an insight as to the way of dealing with it? As one student once put it to me, very succinctly and deceptively simply, he said, "My God," he said, "what in the world is happening in the world?" Now, that's a very simple question to ask, but incredibly complicated to answer. But nevertheless, probably the most important single question that any manager can ask himself. The reason being that what you do as an individual, whether you're a manager or not, is largely dictated by a view that you have of the nature of the universe. Now, that kind of a view of what things are really like is something the Germans have a very good word for. They call it a Weltanschauung, which literally translated is a concept of the world. It's curious and interesting that we have no corresponding word in English. Yet, a Weltanschauung is what enables us to cope with a wide diversity of things and grasp some pattern in them, which provides us with clues for the treatment of these things. But a Weltanschauung has another very great significance. At any time or a period of history, something we call an age exists. We talk about the Middle Ages, the Modern Age, and so on. An age is a period of time which is characterized by a commonly shared view of the nature of the universe, a common Weltanschauung. Now, what I want to propose to you for the first part of my discussion here this morning is a possible explanation for the accelerating rate of change and hopefully a clue as to how to deal with it. Because what I'm going to argue is that the Weltanschauung, the concept of the nature of the world that we share, has started to change in a very fundamental way, and that therefore we have begun since World War II to go out of an age that began with the Renaissance and enter a new age. And we're in a very difficult and awkward period of transition from one era to another, frequently standing with one leg in each of the ages, and as they draw apart, we go into a continually more awkward and painful position. Understanding of the nature of the difference of those two ages, I believe, enables us to deal with the kind of change that you just saw more effectively. At least that's my hope. So the position I want to take then is that we're coming out of an age, which I will refer to for reasons that I hope to explain, as a machine age, and entering a new one, which is very different indeed. Now, the machine age, as I indicated, started with the Renaissance. The Renaissance was a period of transition from the Middle or Dark Ages. And the fundamental change which occurred in that transition was a conversion of focus of man from death to life. During the medieval period, expected life never exceeded 32 years. It was generally in the 28 or 29-year bracket. Imagine, less than half of what it is today. 40% of all the children born didn't survive childhood. The average nuclear family suffered 2 deaths before reaching maturity. 95% of the people lived in dire poverty and conditions of great deprivation. Life was hell. And therefore, the dominant question asked by people during this era was a perfectly obvious one. What meaning is there to life? Why the hell do we live? What's the purpose of it? And the answer that was given by Western religion, Christianity, was perfectly simple. Life is preparatory to death. Death is good and infinitely extended. Therefore, why worry about life? And so we didn't. Man was preoccupied with death. All the great art, the great literature of the time, dealt with heaven, hell, purgatory, what happens afterwards. The sooner we forget what we're in, the better, was the general attitude. As a result, there was virtually no interest in the nature of nature. How little interest there was is actually shocking to us today when we realize it. Let me just cite one historical fact which kind of brings this characteristic of the Middle Ages to light. The first systematic effort to organize our knowledge of nature was made by Aristotle in his great book called The Physics, from which science ultimately got the name. He tried to organize and systematize all of our knowledge of nature, and that was written about 300 BC. And in that book, he formulated the first gravitational hypothesis. His hypothesis went somewhat as follows. If you have two objects of the same size and shape, imagine two balls of the same diameter, but suppose one weighs 2 pounds and one weighs 1 pound. We lift them an equal height above the floor and release them simultaneously. Then Aristotle argued that the 2-pound weight would reach the floor in half the time of the 1-pound weight. He argued the speed of fall was directly proportional to weight. Now we know that's false, but that's not what's important. What's important is that it was 1900 years before anybody thought that was interesting enough to test. And that's incredible to us today, that a hypothesis that's so fundamental about nature was found to be uninteresting for such a long period of time. And it wasn't until the beginning of the Renaissance, when Galileo came along, that he ran the now famous inclined plane experiments to test that hypothesis. It's not surprising, therefore, that the Renaissance is called the Renaissance, which, as you know, literally means rebirth. It was the re-entry of man into the world, full of curiosity, suddenly filled with a desire to understand what it was all about. And he entered it exactly the way a child does. Now, when you give a child something he doesn't understand, whether it's a new toy or he gets a hold of a clock or a radio, and he wants to understand it, what's the first thing he does to the thing? Take it apart. Right. He takes the thing that he wants to understand. The first thing he does is disassemble it. Then he tries to understand the behavior of the parts. Tries to figure out how in the world the parts are operating. And once he understands how the parts are operating, he attempts to assemble his understanding of the parts into an understanding of the whole. It's a three-step process. First, you take the thing you're trying to understand apart, then you attempt to understand the behavior of the parts, and then you try to assemble your understanding of parts into an understanding of the whole. That became the basic methodology of 4 centuries. It's called analysis. The analytical method was the mode of inquiry for 400 years. It became so ingrained in our culture, and even today, most people have difficulty in identifying an alternative to analysis. In fact, we use it synonymously with thinking. You analyze a problem, what does that mean that's different from thinking about it? You analyze the situation, how does that differ from thinking about the situation? Most would have difficulty in identifying any difference between thought and analysis. But as you'll see, such a difference has begun not only to emerge, but to become absolutely critical. Now, it was our commitment to the analytical method applied to the world which led to a series of questions, the answers to which dictated our understanding of the nature of the world. Let me show you how. Suppose this is an automobile, to take a familiar object. We want to understand it. Now, if we proceed analytically, the first thing we do is take the automobile apart. Well, here's a part over here that we call a carburetor. And now, according to this method, we have to understand how the carburetor operates before we can understand the automobile. Task. How do we understand the carburetor? What do we have to do? Take it apart. So we now take the carburetor apart. And here's a part here called a valve. Now we have to understand the valve to understand the carburetor to understand the automobile. How do we understand the valve? We take it apart. Okay? Question. Is there any end to that process? Yeah. The first fundamental question. Now, the answer that was given to that question was dictated by a fundamental belief that permeated over 4 centuries, and that was that understanding of the universe is ultimately possible. That complete understanding was possible. As recently as 100 years ago, in a major conference of the principal scientists of Europe, they forecasted that by 1900, our understanding of the universe would be complete. Isn't that incredible today? But they actually believed we were on the verge of complete understanding of the universe. That was slightly before Einstein. Then all hell broke loose. Now, if you believe that understanding of the universe is possible, then how must you answer the question, is there any end to that process? Yes. Why? Because if there isn't an end, then complete understanding is impossible. If there is, and we understand these things, then we can build up complete understanding of the universe. Therefore, the first fundamental doctrine of the era is, if you take anything in the universe, take any experience of it, and start to analyze it, you will ultimately reach indivisible parts, or elements. And that doctrine is called reductionism. It says that everything consists of indivisible parts. Now, you're all familiar with this doctrine because we were raised with it. In physics, you learn, take any object, start to take it apart, you ultimately reach an indivisible particle of matter called the atom. The atomic theory is a reductionist theory. It says everything in the universe consists of these little particles that have only 2 properties, mass, or matter, and energy. They operate in a space-time coordinate system, and the whole universe can be explained that way. When you were exposed to chemistry in high school, the first day, you remember the teacher handing you a mimeograph sheet? It was a sheet that had a table on it. It was a table of what? The periodic table of the elements. The ultimate forms of matter, hydrogen, oxygen, carbon, and so on. In biology, in the first lecture, you were told that everything that's alive consists of an element called a cell. Psychology, exactly the same thing. It's varied from time to time. The first attempt to formulate psychology as a science was made by a German philosopher, Leibniz, who argued that the mind consisted of psychic atoms. That theory's almost been lost. He called those atoms monads. The reason we've forgotten about all that is that the development of psychology derived out of the work of another philosopher in England, John Locke, who took a very different point of view. He said the mind was like a blank blackboard at birth. It was a receptacle capable of receiving information through the senses and capable of reflecting on what was marked on the board. And therefore, in his effort to understand knowledge, he analyzed experience down to what he called atomic observations, basic perceptions, like the color red. He said, the color red is an atomic perception. Why? You can't define it to a blind man. There is no way you can define red. He said, you can only experience it. And all knowledge is built up out of these basic experiences. Subsequent psychologists came along and said, well, that's fine, but it doesn't explain feeling, the emotional side of life. And so they postulated indivisible elements of emotion called instincts, drives, or needs. We have an interesting development in psychology at the turn of the century when Sigmund Freud came along trying to explain personality, because he reverted completely to the monadic theory of Leibniz. He argued that personality is a resultant of the interaction of 3 psychic atoms. Can you recall what he called them? The id, the ego, and the superego. There are the atoms back again. They were endowed with energy, which he called the libido, but they had no mass. It's exactly Leibniz. In every field of human endeavor, what we saw was a search for the ultimate elements out of which the phenomena were composed. Now, once we got a thing broken down to its elements, and we understood its elements, then we had the task left over of bringing the understanding of elements together to understand the whole. In order to do that, we had to understand what the relationship between the elements are. Now, it's not surprising that in an era in which we thought everything reduced to indivisible parts, that we try to find one single relationship that was sufficient to explain the interaction of everything. And we believed we found it. We call that relationship cause and effect. Science was dedicated to a program of explanation in which only this relationship was used. Now, that's such a familiar concept to us, we don't know what it means anymore. So let me just refresh your mind. To show that one thing is the cause of another, you must do two things. You must demonstrate first that the cause is necessary for the effect. What does that mean? Well, here. You just heard a noise. You saw me strike the easel. Did my striking the easel cause the noise? To show that it did, the first thing I must do is demonstrate that if I had not struck the easel, you would not have heard the noise. That's to demonstrate the necessity. Now, the second thing I must do is show that the cause is sufficient. That means I must show that if I do strike the easel, then you must hear the noise. If I've done those two things, then I've shown that striking the easel is the cause of the noise, which you hear. Now, the use of this relationship to explain the interaction of the elements, again, led to a whole series of questions, the answers to which provide the remaining doctrines that provided our concept of the universe. For example, here's something we want to explain, an effect. To explain it, we look for its cause. Now, the first thing to observe about such an explanation is because the cause is sufficient, nothing else is required to explain the effect. So that once you've identified my striking the easel as the cause, that's a complete explanation of the noise. This has an incredible consequence. There is no need for the use of the concept of an environment to explain anything. As a result, we developed an environment-free concept of the universe. Now, I know that sounds shocking, but let me show you the evidence. This does not mean that we were not aware of something called the environment. What it means is that in science, the concept of an environment was not used in an explanatory way. For example, if I were to ask you to jot down the name of the most familiar law in physics, I suspect most of you would name the one I've already referred to, the law of freely falling bodies. Some of you may even remember the law, S is equal to 1/2 gt squared, but that's not important. The important thing about that law is the word freely. Freely falling body. What's a freely falling body? Vacuum, right. What's a vacuum? The absence of an environment. Every fundamental law of physics tells you how things will behave if there is no environment. But there's even more of a giveaway in the location in which physical research was done. What do you call a place that a physicist does his research? Laboratory, right. What's a laboratory? Sterile. It's a place you keep the environment out of. It's a place deliberately constructed to enable you to study the effect of one variable on another without the intervention of the environment. Our entire effort was to understand things without use of the concept of the environment. That was the first consequence. Second one, if I explain this effect by the use of this cause, in some sense I'm not any further ahead because I've explained the effect, but now I've got an unexplained cause. Now, how do I explain the cause? Well, it's obvious. What will I do? I treat the cause as an effect, right? So I now convert this into an effect and look for its cause. Well, unfortunately, that still leaves me with an unexplained thing. So I'm going to have to explain it in terms as a cause. Question. Is everything which happens in the universe the effect of a cause? Now, if you believe that the universe is ultimately understandable, how must you answer that question? Yes, everything in the universe is the effect of a cause. That doctrine is called determinism. Now, it led to two problems, one of which we solved very simply, the other one of which was a central one that we never did get completely handled. The first is this. If I explain this cause as the effect of this cause, and this cause is the effect of this cause, and this one is the effect of another cause, again, is there any end to that damn process? Yeah. Well, if you believe that understanding of the universe is possible completely, then what must you answer? Yes, there had to be a first cause, and we gave the first cause a name, God. Now, that was the principal proof used for the existence of God by the Christian church. It's called the cosmological proof for the existence of God. And the interesting thing about it is the proof derived from our commitment to cause and effect is the only explanatory relationship. It led to the necessity of postulating a first cause, God. This alone is the only thing in the universe that cannot be explained by cause and effect. It is outside of the domain of science. Okay. Now, that problem was relatively simple. The second one was harder. How the hell do you explain free will? If everything in the universe is determined by a preceding cause, how do you explain the fact that we think we have choice? Well, there never was agreement on this issue, although philosophy took it as the central problem for 400 years. But there was agreement on this much. Whatever free will is, we don't need to understand it to understand the universe. Because it's outside of the domain of science. Concepts like purpose, choice, and so on are irrelevant to science because we can understand everything in terms of determinism. But then what do you do with this damn thing? Well, the general consensus was this. Free will is an illusion. It's an illusion granted by a merciful God who realizes how dull life would be if we really believed in determinism. Because imagine what an awful thing it is to go around feeling that you really have no choice. Everything has been determined. One philosopher summarized it beautifully. He said, man is like a fly riding on a trunk of an elephant who thinks he's steering it. Because it makes the ride a lot more interesting. Okay. Now, if we take these elements and put them together, these basic doctrines and this method, what kind of an understanding of the universe emerged? Very simple. The universe was conceived of as a machine. Not like a machine, but as a machine. The universe was a machine. Hence, machine age. Now, let me take you into an extraordinary extension of this notion. Note, 1. The universe is a machine created by God to do God's work. Every pulpit in the Western world preached this doctrine. What are we here for? To serve his purposes, to do his will. We were part of the machine that he created to do his work. And everything in the universe is a machine part or a machine depending on your focus. Secondly, from Genesis we learn, since we wrote it, that man was created in the image of God. That means that man is more like God than anything else in the universe. As I said, that's not surprising since we wrote that, but we believed it. Now, if you take those two beliefs as premises, there's an incredible conclusion. If the universe is a machine created by God to do his work, and if man was created in the image of God, what should man be doing?
Running the world.
No? Well, he ought to be imitating God. But what was God doing? He was creating a machine to do his work. And out of that came the concept of the Industrial Revolution. It was man's effort to imitate God by creating machines to do his work that led to the Industrial Revolution. Now, the Industrial Revolution was a social movement, every characteristic of which was dictated by these fundamental ideas. We can't go into it in depth here, but let me just give you a feeling for how that happened. The two central ideas in the Industrial Revolution are work and machine. Because the Industrial Revolution was about the mechanization of work. Well, what's work? Well, one thing that Renaissance, and particularly the period immediately after the Renaissance, the Reformation man, was absolutely sure of is that work is no illusion. It is real as hell. It's the most real thing in the world. But everything that's real is reducible to atoms. And atoms have only two properties, remember. Mass, they consist of matter, and energy. Therefore, work had to be defined in terms of those two properties. And it was. If you recall in your elementary physics book, work was defined as the application of energy to matter to change its properties. So when you apply energy to matter, in order to move it, transform it, or change its properties in any way, you have performed work. Now, what's a machine? A machine is any instrument that can be used to apply energy to matter. It's an instrument for work. Now, if you remember chapter 2 of your elementary physics book, it started off by telling you that all machines in the universe are reducible to 3 elementary machines. You remember what the 3 elementary machines are? Sure you do. The lever arm, wheel and axle, the inclined plane. There we are again, reductionism. Everything in the universe reduces to those 3 basic machines. All right, now we have the 2 concepts. How do we go about industrializing? Here's a job to be done. Now, we're not going to be able to mechanize that job until we understand it. That's clear. So to understand it, what's the first thing we got to do? Take it apart. That came to be called work analysis, surprisingly. Now, if we want to understand it completely, and of course you do, if you're going to mechanize it, when we decompose it, take it apart, how far do we want to go? Down to the elements. And so we dealt with something called work elements. What's a work element? Well, we had a very interesting definition. It's a task so simple that it could not be done by 2 people. Tightening a screw. Have you ever had 2 people try to tighten the same screw at the same time? That's a work element because it can be done better by 1 person than 2. Now, why did we try to get work elements? Well, the answer is perfectly clear. If we could reduce work to tasks that are so simple as to be able to be done only by 1 person, then we simplified the problem of mechanization. The easier the task, the easier to mechanize. In fact, many of these tasks could be done by an elementary machine, and that's exactly the way you tighten a screw. You use a screwdriver, but that's an elementary machine. What is it? It's the inclined plane, that's all. It's just an inclined plane with a handle on it. It's a screwdriver. All right, now, we mechanized as many of these tasks as we could, but some we didn't for 1 of 2 reasons. Even though they were elementary, we didn't have the technology available in some instances. In the other case, we had the technology, but it was more expensive than labor. So for 1 of these 2 reasons, we then put people in to do those jobs. All right, now we have a set of elements which we have to assemble into a whole. Well, now you can see what happens. If you take this set of elements and put them into an order, organize them into a whole, what do you come out with? The assembly line, the production line. The modern factory is a direct consequence of the analysis of work. And that has 2 very critical implications for the scene today. The first one is this. If the concept of the current factory is a result of analyzing work, and if, as it will turn out, there's another way of thinking, then there must be another kind of factory. And we have only begun to appreciate that possibility. Something which doesn't look at all like what we conventionally think of as a factory is a lineup of elementary tasks performed by men and machines. Secondly, and more importantly, there's a phenomenon that's come to be known as the irony of the Industrial Revolution, and it really is an irony. Look, in our effort to relieve man of the necessity of work by getting machines to do it for him, we analyzed work into its elements. That was to facilitate mechanization. But since we could never do it completely, there were always tasks left over that we gave men to do. But they were elementary tasks. And therefore, we reduced man to behaving as though he were a machine. We dehumanized work. And that's the great irony of the Industrial Revolution. Now, we're going to look at that problem a little later on. Now, everything I've told you very briefly up to now is stuff you're all familiar with. I've just perhaps given you a little organization of it and a little fancy vocabulary with which to refer to it. We were all raised in this stuff. It's just built into us. By osmosis, we absorb it. But what's been happening since World War II is not nearly as well known to most people. As I've indicated, a new age has begun to emerge. Now, an age doesn't emerge with an event. What happens is something like this. A group of people trying to solve some problem discover a dilemma. They can't solve the problem. They begin to suspect that it's their way of thinking about the problem that's creating some difficulties. And out of this, there begins to emerge a notion that maybe something fundamental has to be changed before we can deal with this problem. Now, another group of people in an entirely different field, you know, maybe these are physicists. coming across the theory of relativity. On the other hand, there are a group of engineers who are trying to develop an automatic pilot that are running into the same damn set of kinds of problems, and they're coming to the conclusion something's got to be changed. And we have a whole series of lines which begin to converge, and eventually consciousness begins to emerge as something fundamental is happening, and some fundamental changes are beginning to take place. And consciousness of a new age only occurs when these people begin to see each other across this space and recognize the similarity of what's happening. Now, this is a long, complicated process, takes place over a great deal of time. The reason I'm timing the new age to World War I is that the first consciousness of a fundamental change began to occur just about at the end of the war. Now, we don't have time to look at all of these paths, but let me just try very quickly to give you a feeling for one of them. In 1942, there was a book that appeared that was almost completely ignored, and for two very understandable reasons. First, it was written by a woman. Now, as you know, any book written by a woman that doesn't deal with sex is ignored. This one didn't. It was even worse than that, because this woman was a philosopher, and who the hell ever heard of a woman philosopher? You know, that's an anomaly. Her name was Suzanne Langer. The book was called Philosophy in a New Key, and it was a report of her research on the natural sciences over the period 1920 to 1940, and she had two fundamental conclusions, as a result of which she was labeled as a nut by the natural scientist. The first conclusion was this. She said that we're beginning to give up the notion that the ultimate explanation of the universe lies in understanding atoms, particles of matter. She said, we're beginning to suspect that won't work. Well, the physicists said she's crazy. You know, we haven't given up the atomic theory at all. But when she went on to her second suggestion, they were absolutely sure she was out of her mind, because she suggested what a new element was that was going to take the place of the atom. And what do you think she suggested? She suggested the new element was a symbol. How nutty could you be? Can you imagine somebody arguing that chairs are made up of symbols? Makes no sense. So she was discarded. Well, she wasn't completely discarded. Some of her students took her seriously. They had to if they wanted to pass. Yeah. So it's not surprising that in 1946, the brightest of her students, a young man by the name of Charles Morris, wrote a book in defense of Langer. And for several important reasons, he was not laughed at. Charles Morris said Langer was essentially right. She had been slightly off. She was absolutely right in saying we're giving up the notion that the ultimate understanding of the universe is to be found in understanding the particles of matter. She was slightly wrong in thinking that we would find it in symbols. He said, in fact, the nature of reality has to be looked for in language, not in symbols. This was Morris in 46. Now, he was not laughed at. There are several important reasons for this. Some of you, I can tell by the color of your hair, were in school with me after World War II. And you will recall that the principal activity on university campuses in the period immediately following World War II, the big intellectual ferment of the late 40s, was the emergence of linguistic analysis, linguistics. It was the biggest thing in academic circles. It was a big fuss. The largest selling non-fictional book in the United States in the 1940s was a book written by Stuart Chase. Any of you remember it? It's called The Tyranny of Words. How the hell come a book about words is a bestseller? Among the best-selling authors in the United States, there was a man by the name of Korzybski. Any of you recall Korzybski or Hayakawa? What were they writing about? Semantics, meaning. The largest selling imported book in the United States during that period was a book from England called The Meaning of Meaning by Ogden and Richards. How come all of a sudden we're preoccupied with language? And the answer was because of the rediscovery of a work of an obscure American anthropologist. You have to be very careful with his name because a little line makes a big difference. Benjamin Whorf. Whorf is responsible for something called the Whorfian hypothesis. Now, Worf was a comparative anthropologist, and he proceeded in the conventional way to study the differences between cultures, and he did it in the following way. He was working at the time we were opening up Japan, so Japan was a great mystery to Western anthropologists, and you proceed as follows. You take the language of the two cultures, English over here, Japanese over here. You list the vocabularies, and then you look for the correspondence. So you got a word for chair here, you look for the Japanese word for chair, and then you link them together. And you go through that process, and eventually you'll find two things, not surprisingly. There are words in English that have no translation into Japanese, and words in Japanese have no translation in English. They are important to the anthropologists. Why? Because they're the clues to the differences in the culture. Now, everybody knew that, but Worf did something beyond that. For example, the word perspective in English had no translation into Japanese. On the other hand, there's a word in Japanese which, when I write in English, is notan. That has no translation in English. Therefore, I can't tell you what it means. You just have to take my word for it. There's such a word. So what? Well, this gave Worf an idea. He went over to Japan. He had a sheet of paper on which he had the following kind of a drawing. And he showed this to the Japanese and said, "What is that?" And none of them said it was a cube. You know how they described this? They said it's a flat surface with a line down the middle and a top and bottom approaching each other. Well, that made Worf curious. So he went back and took a whole collection of Western painting of landscapes, took them over and put on an art exhibit. The Japanese came in droves because they were very curious about Western world. As they left, he interviewed them. He said, "What's your dominant impression of Western art?" And he got a uniform answer from all of them. One word. It's all flat. There is no third dimension in Western art, they said. How many of you have ever seen an exhibit of Japanese silk screens? What's your dominant impression? It's all flat. Isn't that curious? Because it's not flat to the Japanese. And our art is not flat to us. Why? Now, from that, Worf drew the following conclusion. He said, we have always assumed that as infants, we learn about certain things through experience. You learn through experience that this is an object and has certain uses, and eventually you learn the word for it, chair. He said, that's wrong. That's not the way it happens at all. He said, you cannot experience something until you have the word for it. The concept precedes the experience, not reverse. Why? Well, if that weren't true, you would experience perspective without the word. It's only after you give the Japanese the concept of perspective that they can perceive third dimension in Western art. It's only after I explain to you what notan is conceptually that you can look at a Japanese silk screen and see distance in it. But it can be done. So he argued the concept precedes experience. Therefore, if we want to go back and understand reality, where do we go? Back to experience? No. You go back to language, which dictates the content of our experience. And hence, Morris was paid attention to. But that was not the end, because within a year, this was thrown over. There was a precocious young man at Bell Telephone Laboratories that had an idea that he wrote up, and unfortunately, he couldn't write in English. He could only write in mathematics. So he got a collaborator who was a biologist at Rockefeller Institute to translate his work into English. And together they came out with a little book in 1948. The young man's name was Claude Shannon. His collaborator was Warren Weaver, and the book was called The Mathematical Theory of Communication. Shannon argued that it was not in language, but in communication that we will find the ultimate nature of reality. Because language is only one instrument of communication. There is a lot of communication that is not linguistic. Now, curiously enough, Shannon's argument, not his work, his main body of work is still alive, very much. But this particular concept was dead before it was born, for a curious reason, because Shannon's closest friend and collaborator was another mathematician at MIT who agreed with Shannon on everything except this. So he was writing his own book at the same time Shannon was writing his. They finished at exactly the same time, in the middle of '46. Now they had to get their books published. Well, if you remember, that's the end of World War II, and there was a hell of a shortage of print in the United States. It took 2 years to get a book published. Shannon, trying to accelerate the process, went to a university press, because they were a little faster in those days, and Illinois published this book, the University of Illinois Press. But the MIT guy was a little cleverer than Shannon in this regard. By looking around, he discovered there was no shortage of print in France, which had been out of the World War II for 2 years more than we were. So he took his book to France to be published, and it was. And it appeared about 3 months before Shannon's. That book is famous for 2 important reasons. First, it had the largest number of misprints of any book ever published in the English language. That is literally true. The book was called Cybernetics, and it was authored by Norbert Wiener. The second thing is that it was with the appearance of that book that there was the first consciousness that something was really up. In science, they began to talk about something fundamental is happening. Now, what Wiener was arguing in this case is that it's in the meaning of control that we will find the ultimate nature of reality. Now, this is not the end of the process, but just look at what was happening here for a moment. If you start with Langer, you know, we were taking one of these lines in. You start with symbols, and somebody says, no, it turns out not to be in symbols we'll find understanding the universe, but in language. Then somebody comes along, not language, communicate, not communication, but control. What's happening? Can you begin to see a pattern? Very simple. It's so simple, it's difficult to see. Huh? Go ahead, yeah. Right. We began to put the parts back together again. We began to reassemble the elements. But we didn't know what the hell was going on, and that didn't come up until '51. In '51, a book appeared written by a German biologist who had emigrated to Canada. He had an impossible name. His name was von Bertalanffy. I won't even write it down for you. The name of the book was General Systems Theory. The book was relatively unimportant, but the central concept was all important, the concept of a system. Because with the appearance of that concept, we knew what was up. Now let's see what the hell was up. First, since I have to call this new period something, I have no idea what history is going to do. I'm going to refer to this as the systems age for perfectly obvious reasons. But to understand what's going on, we have to understand what a system is. Okay, what's a system? A system is a set of 2 or more elements that satisfies 3 conditions. Now, before I go any further, that tells you something awfully important about a system right now. What does it tell you? It tells you something that it isn't. It is not an irreducible or indivisible part. It's something which can be taken apart. That's the first important thing. A set of 2 or more, I should say, elements that satisfy these 3 conditions. First, every element, I'm just going to use the shorthand, has an effect on the behavior of the whole. For example, take the human body, which is the most familiar system to all of us, right? The heart obviously affects the whole, the brain affects the whole, the liver affects the whole, the stomach affects the whole. Every part of you affects you as a whole. Well, somebody will say, now, wait a minute, don't go overboard. There's at least one part of the human body that has no effect on it. What's it called? There's one part that we haven't found any function for as yet. Appendix, right. What does appendix mean? Isn't it beautiful the way language recognizes the appendix is not a part of the system. It's attached to it. The appendix of a report is not a part of the report. It's something that's added to it or attached to it. If the medical profession ever finds a use for the appendix, they'll have to change its name. Okay? Secondly, the way each element affects the whole depends on what at least one other element is doing. Depends on at least one other element. This is a precise way of saying the elements are interdependent. What's this mean? Well, we're defining a system. It says the way the heart affects the body depends on what the lungs are doing. If the lungs stop operating, the heart can't function. If you damage the brain, it will affect the heart. If you damage the nervous system, it will affect the heart. But change the heart and it will change the brain, it will change the lungs. It says the parts interact. And that's what this says. In terms of the logician would use, he says the parts of a system are connected. Now, it's the third condition of the system, which is really the critical one, and gives an insight to why there's a revolution in this concept. If I take the elements of a system and line them up, however many there are, it doesn't make any difference. And now I'm going to form subgroups out of these elements. And I don't care how it's done. You can do it at random, you can close your eyes and throw darts, it doesn't make any difference at all. But we're going to form subgroups of these elements. Okay? Then, no matter how I do this, these groups will have these two properties. That is, every group of elements will have an effect on the performance of the whole, and no group will have an independent effect on the performance of the whole. Now, why is that so radical? Well, let's see. That means that I cannot divide a system into independent parts. Now, why is that so radical? From that, it follows that every system has properties that none of its parts do. Now, that's perfectly obvious when you stop and think about it. You can read, you can write, you can run, you can play tennis, you can make love, but no part of you can do any of those things. If I take you apart, I cannot observe your essential properties. Therefore, a system is a whole which loses its essential properties when taken apart, and therefore it cannot be understood by analysis. And therein lies the revolution. We began to realize that the universe is populated by things called systems that we cannot understand by the method to which we have been committed for 400 years. We needed a new method of thinking, new way of thinking. And one emerged. It came to be called synthesis, not surprisingly, but that's not the popular term for it. It's actually usually referred to as systems thinking. Now, what's systems thinking? It's exactly the opposite of analytical thinking. Remember analysis? You took something you want to understand, take it apart, explain the parts, and then assemble the understanding of the parts into an understanding of the whole. So if you have a university and you want to explain it, you're an analyst, how do you do it? Well, a university consists of parts called a college, right? The college is not an element, so we'll take the college apart into elements of the college called what? Departments. Now, the department can be taken apart. It turns out to consist of three elements. The department consists of students, faculty, and subject matter. Now, once we've done this, if we can define these three, and it's pretty goddamn hard to define a faculty member, but if we've defined a faculty member, student, and subject matter, now we can assemble them into a department. A department is a configuration in which faculty who presumably know a subject matter try to transmit that knowledge to a group of students who presumably don't know it. Now we can define a college as a configuration of departments with related subject matter, and so on up till we get to a university. That's analytical. What's the synthetic approach look like? There's the university. Instead of taking the thing to be explained as a whole, which is going to be taken apart, we will take it as a part of a larger whole. First step, identify something that contains the thing to be explained, a containing system. It's going exactly the other way. So, for example, in the case of a university, what system is a university a part of? Education. So we say the university is a part of the education system. Second step, explain the behavior of the larger system. Explain what education is. Third step. Now you explain the university in terms of its role or its function in the larger system which contains it. Now notice that's completely different from analysis. In analysis, what we deal with is structure. In synthesis, what we deal with is role or function in the larger whole. Now we began to understand something we hadn't understood before. Analysis never yields an explanation of anything. What it does is tell us how the thing works. It lets us know how a system works. It gives us know-how, or knowledge, but not understanding. Synthesis does not yield knowledge, but yields understanding. Therefore, they're complementary processes. They both have a role. But if we want to understand the system, we cannot proceed analytically because when we take it apart, it loses its essential properties. Now, the emergence of this way of thinking has immediate and incredibly radical implications to management. Let me show you the principal one first, and we'll come back to it a little later. The implication is this. The traditional way of managing is not surprisingly analytical. You're confronted with a situation that you have to do something about. What's the first thing you do? You analyze it, you decompose it into solvable parts. A corporation is exactly this. What's a corporation? It's a marketing department, a purchasing department, a production department, so on. What are those things? They're parts into which the whole has been divided. Why? Because you say, if I can divide it into smaller parts and then operate each part as efficiently as possible, then the whole will operate as efficiently as possible. That's analytical thinking. And it's absolutely wrong, it turns out. Because we can prove, rigorously prove, the following theorem. If you take a system apart and make every part operate as efficiently as possible, considered separately, then there's one thing you can be sure of about the system as a whole. It will not be operating as efficiently as possible. And yet our whole method of management is based on the decomposition of the whole and improving the performance of the parts. Now, I can't take you through that proof. That would be much too complicated. But I'll give you a very simple and recognizable example which will show you how valid it is. There are 142 makes of automobile in the United States. Let's buy one of each and bring them into a large garage. Hire a group of automotive engineers, bring them in and ask them to do the following. There are 142 cars. Test them anything you want to do. Do it. Tell us which one's got the best carburetor. They run a series of tests and they come out and they say, well, the Mercedes has the best carburetor. So we make a note, carburetor Mercedes. We say, fine, gentlemen, now take the transmission and do the same thing. They run through the 142 cars, come out and say the Cadillac has the best transmission. Then we say engine, and they come out with the Rolls-Royce has the best engine. Horn, the Volkswagen has the best horn, and so on. And when we've got a complete list of all the parts and we know which one is the best available, we tell them to remove those parts from the cars and put them together into the best possible automobile. Is that what you get? You don't even get an automobile. For the perfectly obvious reason that the parts don't fit. In a system, the performance is never the sum of the performances of the parts taken separately. It is not the sum of the actions of the parts. It is the resultant of their interactions. And that's a fundamental difference. Now, we're going to look at some of the managerial problems that arise out of this. But the first moral of all this is that if we're going to cope with the accelerating rate of change in the world that we live in today, we're not going to be able to do it by analysis. Not even systems analysis. It's going to have to be done by systemic thinking. Now, I can't take you in detail through what's happened to each of these ideas, but let me just sketch out so you can see quickly what's happened. You can see what happens to reductionism. If I have to explain the university by explaining the educational system first, how do I get to understand the educational system? What do I have to do? I got to put it in a larger system. Society. How do I explain society? And here we are off again, but in the other direction. Is there any end to that process? The answer is it doesn't matter, because a very fundamental thing happened in the 1920s. We gave up the belief that we would ever understand the universe completely. There was a very famous book written by our greatest philosopher, John Dewey, called The Quest for Certainty, in which he said, man has finally given up the notion he will ever understand anything completely. It's an ideal that we will continually approach but never attain. Now, the moment you give up that idea, what happens to the question, is there any end to the process? It doesn't make a damn bit of difference, because you're never going to reach it even if it exists. So what's the point of arguing? But we do know this, that whereas for centuries we believed that understanding must begin with the elements and build up to the whole, we now believe it goes the other way. You will never understand an atom until you understand the universe, not vice versa. Understanding proceeds from the containing whole to its parts, not from the parts to the whole which contains them. And that doctrine is called expansionism. Now, it turns out also that there's an alternative to cause and effect. I wish there were time to take you through the development of that idea and its emergence. It's called, under various names, some people call it probabilistic cause and effect, some call it non-deterministic cause and effect, but that's weaseling, because they're contradictions. It is increasingly referred to as producer-product. Now, a producer and a product are very different than a cause and effect. Why? Take an acorn and an oak. An acorn is a producer of something called the oak. Now, like a cause, it's necessary. You cannot get an oak tree without an acorn, so it's necessary. But unlike a cause, it is not sufficient. If I take an acorn and throw it in the ocean, I don't get an oak tree. Put it in the Arctic ice cap, I don't get an oak tree. Therefore, a producer is something which is necessary but not sufficient. Now, the man who first came up with this observation, an American philosopher of science, E.A. Singer, when he first saw this relationship, he essentially argued as follows. He says, the universe is like an orange. Suppose you've never seen an orange before, and you want to find out what it's like, and you slice it down the middle. What would you see? Well, what you'd see is something that looks like this, right? Well, not necessarily. You might not see that at all. If we slice it the other way, what you would see is something that looks like this. Now, no, these are two entirely different views of the same thing. Therefore, Singer argued there's an infinite number of different ways of viewing the universe, not one. And so he devoted his life to slicing it the other way through producer-product, and he discovered some very interesting things. First, if here's the oak tree, and we want to explain it, we come back looking for its producer, and we find the particular acorn from which the oak grew. Do we have a complete explanation? No. Because the acorn was only necessary. To get a complete explanation, you must know what all the other necessary conditions were. But the sum of the other necessary conditions is called the what? Environment. And so suddenly the environment becomes necessary to explain everything. From a concept in which the environment was required to explain nothing, we went to one where it's required to explain everything. Environment full. Finally, what about determinism? Well, it's perfectly clear that the acorn doesn't determine the oak. At best, it partially determines it. You can't get the oak without the acorn, but given the acorn, you have no assurance that the oak is going to fall. It depends on other things. Therefore, it turns out that freedom of choice, free will, and purpose become perfectly meaningful in this view of the universe and can be incorporated systematically into science and studied objectively. And that doctrine is called teleology, which is simply the Greek word for purposeful. So what comes out of all this? A very different view of the universe. The universe is no longer perceived as a machine consisting of other machines or machine parts. But the view that emerges from all this is that everything that we're interested in can be looked at as a system. Furthermore, every system is contained in other systems, and the system of primary interest is a teleological or purposeful system. Why? Well, for centuries, we looked at what we now think of as a purposeful system. You are a purposeful system. We thought of you as a part of the machine. Today, we do exactly the reverse. Every machine is an instrument of a purposeful system. If you reflect, that's exactly what we did in the machine age, but didn't get conscious of it. Because the machine, the universe, was an instrument of God who had purposes. Therefore, the prime attention goes to the purposeful system. But not just any one. We have interest in a particular kind of purposeful system. There are two kinds of purposeful systems. All systems, and particularly purposeful ones, have parts. Now, the parts are either purposeful or they're not. Well, first let's consider a system in which each part has a purpose of its own. That kind of a system is called a group. Now remember that a part is defined by its role or function in the whole of which it's a part. But now suppose I have different functions for different parts. Then I have something called a functional division of labor. Now a group with functional division of labor is what kind of a system? What do you call it? It's an organization. So it's not surprising we focus on organizations. But now suppose you have a system whose parts are not purposeful, but we have a functional division of labor among them. Can you recognize that system? It's the other important system. That's an what'd you say? I didn't. Committee. Pretty good. That's an organism. The human body. There's a different function for each part, but the parts do not have purposes of their own. And then finally, there's a machine, which is a non-purposeful system. All right. Every system has parts. We're particularly interested in the systems which have parts that have purposes of their own. And every system is embedded in a larger system. Therefore, today we think in a paradigm, a model of thought, which always involves three levels of system. The containing system, the system, and the parts, or subsystems. Subsystem, system, and supersystem. Implication. We have come to realize that we've had an incomplete concept of management, because traditionally management has been looked at as follows. Management is performed by a group of purposeful elements, people, who have a common function within a system, and that function is the control of the system of which they are a part. To manage a system is to control it from within. Therefore, management has been identified with the problem of self-control, self being the system. But it turns out that's only 1/3 of management, and the other 2/3 have been completely ignored throughout the emergence of the field. There's a second function of management. The second function is how do you run the system in such a way as to serve the purposes of its parts more effectively, and by so doing, more effectively serve the purposes of the system. And that's called the humanization problem, and it's probably the most pervasive problem in the world today. The women's liberation movement, the racial problem, the third world movement, the alienation from work, the generation gap, are all varieties of the humanization problem. How come? Well, look. In every one of those cases, you have parts of a system, purposeful parts of a system, organizing to protest against the way the system is serving their interests. It's a failure of management to effectively serve the purposes of the parts that's producing those crises. Because those parts now see themselves as having purposes of their own, unlike the worker of the 19th century who thought of himself as a machine part, a replaceable machine part. Thirdly, how do you run this system in such a way as to effectively serve the purposes of the containing system? And do that so as to serve the purposes of the system. And that's called the environmentalization problem. And that's equally pervasive. consumerism, the ecology movement, the environmentalist bit, the whole thing is part of this problem. Why? In each case, you have elements outside the system that are affected by the system, organizing to protest about the way the system is affecting them. It says the system has a responsibility for its impact on them outside the system. Therefore, management has to look in three directions simultaneously: the self-control, humanization, and environmental problems. Now, we could spend a day on each one of these and the emerging technologies which are beginning to appear. But these are not separate problems. They're three aspects of the same problem. For example, a little reflection will show you that what is an environmental problem from the point of view of the individual worker is a humanization problem from the point of view of the system. So these are simply complements of each other. Well, there very quickly is an attempt to give you an idea of what's going on and why, and to indicate the emergence of methods which begin to give us some hope for being able to cope with increasing rates of change and increasing complexity. Now, for the remaining time, what I'd like to do is turn this into marketing and take a look at some of the problems of marketing very quickly with you to give you a sense of how we can do some of these things. I'm going to deal just with three questions that come out of marketing and show you how systems thinking can be applied to it. The first point I want to make about marketing, which derives from systemic thinking, is that there is no such thing as a marketing problem. That's an illusion. There's no such thing as an economic problem, or a moral problem, or a social problem, or a political problem, or a chemical problem, or a biological problem. Those are fictions. There was a little old lady who died in an urban black ghetto just to the north of the university. She was walking up a flight of stairs on her way to her fourth floor, one-room walk-up. She had a heart attack and died. There was a meeting in the community subsequently to find out what could be done to avoid that kind of thing in the future. The doctor who was present said it's perfectly clear what we need is a clinic that's available with doctors who are on call for old people who can't climb stairs. He says, so it's very simple. All we got to do is get more medical facilities in the community. He saw it as a medical problem. Okay? The architect who was present said, hell, there's an easier way of doing it. If we had elevators in all the buildings, you wouldn't have to climb the stairs. He saw it as an architectural problem. The economist who was present said if she had more income from welfare, she wouldn't have to live in the fourth floor walk-up. So increase her income and you wouldn't have this. The social worker who was present said, no, you've all got it wrong because she has a very affluent son who lives in the suburb, but she's alienated from her son and not living with him. If the family structure was sounder, she would have been taken care of. What kind of a problem is that? Is that a medical problem, a social work problem, an architectural problem, or what? It's none of those things. It's a problem. Those things are points of view. And any problem can be looked at from any point of view. The first important moral for marketing is there is no such thing as a marketing problem. There is a problem that can be looked at from the marketing point of view. But what do we do? What we do is this. A problem arises out of the recognition of symptoms. So here's a whole complex system, and over here you observe some systems in a part of it. You therefore label the problem by the part of the system in which you observe the symptom. You have a headache. What the hell's a headache? It's an ache in the head. But now in management we do something that the doctor doesn't do. The doctor doesn't necessarily try to cure a headache by treating the head. But that's exactly what we do in management. If sales are off, that's a symptom, we got a marketing problem, and then we try to solve it in marketing. But the chances are it's more effectively solved outside, somewhere else in the system. Therefore, the first thing that grows out of systemic thinking is this, is marketing is everybody's problem. The problem is not to get a better marketing department, but to get everybody doing better thinking about the market. Let me tell you about a simple experiment that I've run in class a number of times. This is a very difficult point to make to most people, what I've just said. And to students, it's very difficult, even more difficult, because they haven't had the kind of experience you've had. I take a basic course in operations research called Production and Inventory Control. It's a standard course, and they go through learning mathematical techniques for optimizing inventory and flows and schedules and all this kind of stuff. I tell the students at the beginning of the course we're going to accelerate it and cover the textbook in half a semester by leaving some things out and going lightly over others. That they're to do the exercises at the end of each chapter, turn them in, they'll be graded and returned, but they better not lose them because they're going to need them for the second half of the course. Well, they want an explanation, but I refuse to give it to them. Halfway through the course, I tell them to throw away their textbook and bring out the first set of exercises again. They've already been graded. They say to me, okay, now what do you want us to do with them? I say, I want you to resolve those problems. But now you cannot touch anything in the production department. And I always get the same response, you must be nutty. The first problem that they have in the set is they got a production line, and there were 15 products waiting to be produced. The problem is in what order to produce those products so as to minimize the setup time required on the production line. They said, how the hell can you solve that problem outside of production? It's obviously a production problem. See, it's exactly like a doctor saying the only way to solve a headache is brain surgery. But that's exactly what they're doing. I said, you're going to have to solve it outside of production. Now, for 2 weeks, they fight like holy hell. Finally, they decide that I'm incorrigible, and even though I'm nutty, they're going to have to try to do it if they're going to pass the course. And now they start to try to do it. And then two very important things happen. First, they discover they can do it. Not only do they discover that, but they discover that most of the solutions they get are better than the old ones that they had. And then, of course, they take credit for having discovered that themselves. Invariably, this happens. Now, about a month from the end of the semester, when they're now very cocky and self-satisfied. One day I tell them, next time you come to class, bring that first set of exercises in again. And they say, oh my God, what the hell's he up to now? And they come in and I say, now I want you to solve those problems without touching anything inside the corporation. They don't fight quite as hard now, and they discover two things. First thing is there's no problem that occurs inside a corporation that can't be solved outside of it, and most of those solutions are better. Now, what have I just described to you? That's expansionism. That's what the principle of expansionism is. It says you try to solve every problem in the largest system to which you have access, and move down only if you have to. The traditional way is exactly the opposite. You try to solve the problem in the smallest system that you can get to, and only get larger unless you have to. We even have a name for that. You call that cutting a problem down to size. That's exactly what makes most problems unsolvable. Let me give you a simple, real case. A few years ago, in the mid-1960s, a great thing happened in England. I lived in England in the early 1960s. In the early 1960s, central heating virtually didn't exist in England. The English have a remarkable capacity to endure and enjoy discomfort. We lived in a flat provided to us by the university that I was visiting that year with my family, and we had 7 different sources of heat in it, 7 local heating places. And every damn morning, it took me an hour and a half to get the place stoked up. In fact, my little boy at the time, he was 8 years old, had a little toy bugle. And every morning, we'd get out in the hall and blow the bugle to wake us up and then yell, everybody out of the house to get warm. And that was literally the case. Now, in the middle 1960s, they began to bring in central heating for the first time. Now, I won't bother to tell you the differences between their central heating and ours. It's really funny. But they started to get the houses warmed up. They got all the way up to 64 or 65 degrees. Now, when they did that, it was a very important unanticipated consequence. Their food began to spoil. Because in England, all I used to do was leave the food laying around. The house was so damn cold, nothing ever happened to it. Every house had what is facetiously called a cold room. Christ, every room was a cold room. But now they had to have refrigerators. Now, refrigerators were around England, but you wouldn't believe them. In '61, when I was there, we had a 2.5-foot cubic refrigerator. It was just large enough to hold milk and butter if we didn't get a big bottle. But refrigerators came in, and with refrigerators came freezers. And the possibility for frozen foods entered Britain in the middle 60s. Now that's the thing. The largest food producer in the world, believe it or not, is the Unilever Corporation, which is headquartered in England. When Unilever saw the freezer coming in, they said, we got to get in the frozen food business. That's a big thing over in the United States. We got an opportunity here. What should we enter the business in? The answer was easy, fish. Why? Because fish is the principal form of protein in the British diet. Well, there was also another very good reason. Unilever is a completely integrated fish company. They have their own trawlers, their own fishing fleet, they have their own processing plants, and they got the largest chain of retail fish stores in the world, McFisheries Limited. So there they are, it's ready-made. So they went into the frozen fish business. How? Well, when their trawlers came into the docks, they have the packing plants back here, they simply set up freezing capabilities there. Then they took the retail stores and they put freezing compartments in. And in a very short time, they were producing frozen fish. And they advertised like mad, introducing the British housewife to a complete innovation of food, frozen fish. And the British housewife was curious as holy hell, and they had an incredible sale for the first couple of months, and it went to hell. The market just disappeared on them. Well, they had invested millions in all this, so they called in the market researchers, sent them out to the field and said, what's wrong? Well, they came back and said, women say the fish don't taste good. Well, what do you mean it doesn't taste good? Well, it's not that it's bad, it's just flat. It doesn't have as much flavor as fresh fish. So they got a taste panel, a professional taste panel, to test this stuff and blindfolded, and they found, by God, that's true. Frozen fish is flat. It doesn't make a difference whether it's bluefish or cod. It tastes the same. So they called the food chemists in and said, how come frozen fish loses its flavor? Well, the chemists did a long study and came back, and I can't explain the chemistry, but this is basically what they said. When you catch the fish on a trawler and you pull it out, you throw it in the hold and ice it down. It dies, it drowns in air. When a fish is dead, there are chemical changes that take place in the body. Those chemical changes, combined with freezing, results in a loss of flavor. Therefore, you either have to keep the fish alive until just before you freeze it, or you'll have to freeze it right where you catch it. So now Unilever called in the engineers. He said, look, we got two choices. We can put freezing capability on the ship and freeze the fish when we catch it. Or we can try to keep the fish alive on the trawler, bring it to shore, and then freeze it. Which is the cheapest? So they did a cost-benefit analysis and came out and said, keep the fish alive. Line the holds of the trawler with water-proof material. Fill it with seawater. Dump the fish into the holes. And they'll swim around till you get to shore. Then you pull them out, clean them, and freeze them. So Unilever set up a whole damn process, came out with the most frank advertising campaign probably in the history of England. They said, Mrs. Housewife, we goofed. We screwed it up terribly. But we got it solved. We now have a new frozen fish that's really good. Please try it. And the housewife was overwhelmed by the frankness. Imagine Unilever saying they goofed. So they went in droves to try the new frozen fish, and for a couple of months they had the best damn sales you can imagine. At the end of 3 months, boom. Out go the market researchers again. What's the matter? Well, it's better than it was, but it's nowhere as good as fresh fish. Why not? It's flat. Back come the food chemists. What's wrong this time? The food chemists came in with very red faces and said, look, we were not wrong, but we misled you. Everything we said was true, but we didn't quite have the right explanation. You see, they said it's not the fact that the fish is dead. It's the fact that the fish isn't moving, because it's the lack of motion that produces the chemical change. Now, what's happening on the boat is you're getting that hold so full of fish, even though they're alive, they can't move. And the muscles begin to atrophy. And that change, together with the freezing, results in a loss of flavor. So imagine, so what the hell do we do now? They said, you got to get those fish to move around. Back come the engineers. They took a laboratory and they built a hold of a ship. They set this damn thing up on scaffolding, and they mounted it on 2 axles so they could rotate this thing either way. They mounted up on top here a set of outboard motors. They filled this thing with seawater and fish, and they started to beat holy hell out of that water to figure out how to make the fish move. And no matter what they did, those damn fish sat there with a little twitter of their gills and stood still. When you got the density up to a certain point, the fish just refused to move, no matter what the hell they did to the water. And the engineers were going nuts. Now, by sheer accident one day, there was an engineer sitting up here beating holy hell out of the water with an outboard motor, just out of anger. He had no hope anymore. And down at the bottom here, there was one of the consultants of the company walking through, a guy who was by profession as a piscatologist. Now, a piscatologist is a natural historian of fish. And he saw this engineer up top. You know, all he saw was his rear end, but he recognized it. And he yelled up to him. He said, "What the hell are you doing up there?" And the engineer looked, he said, "Hey, Doc, come on up." And so the guy climbed up the ladder to the scaffold and said, "My God," he said, "what are you doing?" He said, "We're trying to get those fish to move." And he explained the problem to the piscatologist, and the guy listened for a while. And then the engineer got preoccupied again with beating the water, and while he wasn't looking, the guy started climbing back down the ladder. And he suddenly looked up and saw the guy was gone, and he looked down the ladder. He said, "Hey," he said, "before you go," he said, "you got any ideas?" And he said, "Yeah, as a matter of fact, I do." He said, "Why don't you throw a shark in there?" Now, believe it or not, today, every trawler of Unilever has 2 baby sharks in each hold. They lose a couple fish on the way back, but goddammit, they're the best exercise fish you've ever seen. The fish has marvelous flavor, and they've lived happily ever after. Now, what kind of a problem was that? Now, you have to treat marketing the same way. Therefore, it seems to me that the moral which this course is trying to make isn't just a pious wish. It says everybody in the company in Bell has to think marketing, because there's no such thing as a marketing problem. There's a marketing point of view. And by the way, if you're in engineering, it means that everybody's got to think engineering, and everybody's got to think production and purchasing and so on, because you have to think in terms of wholes, not parts. So that's the first point I want to make. The second point I want to make about marketing that brings us back is that what you thought was understanding in the past wasn't. It was knowledge. You remember the distinction I made between knowing how something works and understanding it. You don't understand your consumer at all. You think you do. Hell, you don't even understand yourself, but you think you do. Let me give you an idea of the general depth of understanding that most of us have of consumption. A few years ago, we were doing some research for a large candy company. And they operated in 23 countries at that time. So we got the statistics from each of the 23 countries and studied the trends, and we found some were going up and some were going down. But there was a tremendous variation in per capita consumption. So we tried to look for some clues. GNP, population growth, and all kinds of things. We couldn't find any. I was particularly struck, because I live in England, with the fact that the English consume almost twice as much sweets as the American does. If you've lived there, how many of you have ever spent any time in England? Oh, great. Well, then you know that sweets in England, which is what they're called, have very different roles than in the United States. All you have to do is look at television to tell that. You wouldn't believe, those of you who haven't seen it, an English commercial for candy. Absolutely inconceivable. You know, here it's always little cartoon characters, amusing kids. In England, it's not. First, you see the most handsome woman you've ever seen in your life. Oh, my God, is she seductive. Then comes this absolutely handsome man. Then he starts to try to seduce her. Then when they reach the virtual point of consummation, he reaches in the pocket and offers her a bar of candy. Now, when you see that enough times, you begin to realize that candy is very important in England. Okay. So it occurred to me, maybe we can explain consumption of candy in terms of consumption of sugar. So we looked up sugar consumption. It's exactly the same as candy, you know, ratios. That gave me an idea. I called a friend of mine who's vice president of marketing at one of the largest sugar companies in the world. And we chit-chatted for a moment. I said, "Hey, Bill, I just ran across the fact that the English consumption of sugar per capita is twice as much as the United States, approximately." I said, "Are you aware of that?" He said, "Of course." He said, "Everybody knows that." I said, "Well, that's great." I said, "You know why they eat so much?" He said, of course, everybody knows that. I said, oh boy, that's a relief. Why? He said, they like it more than we do. I said, Bill, how do you know that? He said, what the hell, they eat more, don't they? Now, that's about the general level of understanding of consumption. You don't know why people use the telephone. You know how they use it, but you don't understand why because you've never tried to. You haven't raised the question of explanation. You've only raised the questions of know-how. Now, let me give you a simple example of what happens when you don't have understanding. When you don't have understanding, you develop a strategy based on what you assume is an explanation for the consumer's behavior. And then it doesn't work. Now, how do you explain the failure? Invariably, you say the consumers are rational. That's the standard explanation. You come out with a product that's obviously superior to any other product, you put it on the market, and he refuses to use it, you say he's nuts. Now, there's one thing about such an explanation. You can't learn anything from it, and there's nothing you can do. It's a paralyzing explanation. Okay? Now, let me give you an example that will make tomorrow. In 1957, I was invited to India to do an evaluation of their second five-year plan. I was invited over by the chief planner in India, a very famous professor, Mahalanobis. Mahalanobis was a marvelous guy. He was an old personal friend, and so we were invited to stay with him at his institute in the guest house. Now, he felt very obliged to keep my wife and I, my wife was with me, occupied socially. So every goddamn night he had a party. Now, that wasn't so bad. But what was really bad is he decided that what we wanted to do while we were in India is spend our time with Americans. So he had a whole crew of people running all over India, finding Americans to bring them into these damn parties. Now, it turned out in '57, almost every American in India was there for one or two reasons, either from the State Department or from the Ford Foundation. Almost all of them. And they were all doing the same thing. What do you think they were trying to do in India? Family planning. So night after night, I heard about family planning. And I never saw so many frustrated people in my life because they pointed out they had spent millions and millions of dollars over 10 years and they had absolutely no effect on the birth rate in India. They were distributing expensive contraceptives for no cost. It was the IUD in those days with family planning courses. And the only impact they had had is reduce the birth rate of cows because the Indians would take these devices and insert them in cows. Now, they told me night after night, they said, Russ, they said, these people are simply irrational. They got this screwball religion, they got matcha, they got all kinds of things. These people are irrational, we can't reach them. Now, after I heard that for a couple months, I started to get fed up to here. So one night, just to have some fun, you know, I was just bored stiff. When a group of them hit me this way, I said to them, look, did it ever occur to you that maybe they're rational and you're not? And they said, well, don't be silly. You know, how can anybody be rational who refuses to hold population down when clearly the population is growing faster than the GNP and therefore poverty is increasing? How can that be rational? I said, well, I'm not sure, but I do know this, that as long as you continue to believe that they're irrational and you're rational, you can't do anything. So why don't you at least assume to have some fun the other way around and see what happens? They said, no, that's a waste of time. I said, well, I'm not sure it's a waste of time because there's at least, I can think of one fact which disturbs me a great deal about your explanation. They said, what? I showed him a clipping. It happened, there was an English newspaper published in India which I used to get daily. It gave me the illusion of keeping in touch. And among the important news events one day, there was a little tiny box in the bottom left-hand corner of the front page which pointed out that a woman in Brazil had just had her 42nd child. 42 children. So I said one night to the guys from the Ford Foundation, I said, look, I know of at least one case. Now, I carried this clipping with me of a woman that had 42 children. I said, now in India, where you have one of the highest birth rates in the world, in the average family, you have 4.6 children. I said, now the thing that really impresses me is not that the average woman has this many children, but it's the fact that there are 37.4 children that she could have that she isn't having. Therefore, it doesn't seem to me it's not a problem of control. Because somehow or other she's managing not to have 37 kids that she could have. So it's no lack of control. Maybe she wants that many kids. He said, I remember this guy, he said, Russ, he said, you really are out of your field. Well, fortunately for me, by sheer coincidence, one of the Indians sitting around the side of this conversation was the chief demographer at the Planning Institute, a man by the name of Balakrishnan. The next morning he came to my office, he said, hey, he said, I really like that idea. He said, I'd like to work on that problem if you give me some help. So I said, yes. Now, let me just describe very briefly what happened. We start off by assuming now that the Ford Foundations are rational and the Indians are rational. We begin to look for facts which might explain what the Indians are doing. Well, first fact. India got its independence in 1947. We were there in 57, 10 years later. First fact. In 1947, expected life in India was 37 years for those who survived childhood. In 10 years, the major accomplishment of the Nehru government was to increase expected life, largely through sanitary engineering. It had gone up to 57 years. It had increased 20 years in a 10-year period. The expectation. Now, second fact, employment. As you know, India has one of the lowest employment rates in the world. The labor force is so much larger than the labor required that the average Indian can only work for 20 years of his life. Because after he's worked for 20 years, he's essentially physically worn out, and there are a whole bunch of young kids who can be hired for the same cost who have a lot more energy. So the average Indian works for 20 years, and that had not changed. But now put the two together and look at what happens. The average Indian goes to work at about 15 years. He works 20 years, that gets him up to about 35. So just about the time he's no longer employable. In the past, he conveniently died. But now look what happens. The average Indian had 20 years of unemployment to look forward to. Now, how the hell is he going to survive? Well, retirement benefits. The average income of an Indian worker was $50 a year. You don't retire on the savings out of $50 a year. Private insurance, you can't get it out of that money. Destitution in India is a very real thing. On the streets of Calcutta, every morning, at 5 o'clock, a fleet of trucks go out to pick up the dead bodies. They pick up between 2,000 and 5,000 dead bodies off the streets every morning. People who simply die in complete destitution. That's not a vague abstraction. That's the big fear in India, of being left to die of starvation. How do you protect against it? Well, it's perfectly obvious. If I got 20 years of unemployment and 20 years of employment, I better make goddamn sure I have kids to support me. How many should I have? Question. If I take one employed person, how many unemployed people can he support on the average? Or let me put it a little different way. If I want unemployed people at the minimal subsistence level as defined by the World Health Organization, how many wage earners do I require to support him at that level? The answer turns out to be 1.2. All right, now, unfortunately, the man can't produce a child by himself. So he has to have a wife. So that means he's really got two over here. Therefore, you need I'm sorry, I got this wrong. It's 1.1. Therefore, you need 2.2 wage earners to support the husband and wife. Well, not quite. Now, first of all, women were unemployable in India. Only males are employable. Therefore, how many kids do you need? Well, not quite. Why not? Because of the mortality rate. How many do you need to have an expected number of 4.4 survive? 4.6. Which says that the Indians are optimizing the number of children they have. Now, you might say that's a sheer fiction. The numbers just come out that way. Well, it's not, and it's very easy to show how. Because if this explanation is right, suppose you look at an Indian family whose first child is a son, whose second child is a son, and whose third child is a son. What would you predict?
No more.
No more. But suppose they had 3 daughters in a row. Well, hell, they're just getting warmed up. And that's exactly what happens. That's exactly what happens in India. If they have 3 sons in a row bang, they've had it without the help of the Ford Foundation. Okay? Now, once you know and understand why they're having 4.6 kids, you can do something about it, and contraception is not relevant. Now, the same point can be made about your system. You're making all sorts of changes in your system which are intended well to serve the consumer, but you don't understand what the consumer wants or desires, and he doesn't either. I can't go ask somebody, why do you eat more sugar than I do? It took us 18 months to find the answer to that question. It has to do with the ratio of protein to carbohydrate in your diet. Can you imagine the guy saying, well, I have a high ratio of carbohydrate to protein in my diet? You don't know why people use the telephone the way they do, but you better start finding out. Understanding. Finally, the last point I want to make is that you tend to think of your product analytically. What business are you in? Communications. Communications. You've managed to get yourself out of the telephone up to the communication business. Right. Can you go any further than that? Well, what's communication? Communication is the transmission of symbols. If you're in the communication business, you're in the business of symbol transmission. But there are other things we do with symbols. For example, if you go back in history, your technology emerged in the middle of the last century. It began with the telegraph, right? Roughly 1850. At exactly the same time, and not surprisingly, because the telegraph required electricity, the telegraph was one of the first instruments to begin to use electricity as a commercial source of power. Now, there's a curious thing about electricity. You can't see it. Therefore, if I want to know how much is going through a wire, I can't look. Furthermore, it turns out if I whip my finger and try to feel it, that's pretty dangerous. So what do? We developed a gadget to do it for us, an instrument, the ammeter, the voltmeter, the ohm meter, and so on. Now that's an interesting gadget. It has a property in common with the telephone. Neither one of them do any work. Remember, work is the application of energy to matter to change it. Telephone doesn't do any work. It's a symbol transmission machine. Well, what is an ohm meter? It's a symbol generating machine. Symbol generator. If we call symbol transmission communication, what do we call symbol generation? You know? Observation. These are machines which observe. The gas gauge in your car is an observing machine. It generates a symbol which represents the properties of your gas tank. Now, these two technologies sat around for 100 years developing, just as yours did, but the explosion didn't occur until the middle 1940s, and you are vaguely aware that it occurred, but I don't think you really yet understand what the nature of that explosion was. The explosion was the ENIAC. You know what the ENIAC is? It was the first electronic digital computer. What's a computer do? Don't tell me compute. You know, that doesn't mean anything. What does it do? What's it actually do? It manipulates symbols. It's a symbol manipulating machine. Now, if this is observation and that's communication, then what's symbol manipulation, you know? That's thinking. That's exactly what thinking is. That's why the computer is called a thinking machine. Now, if you stop analyzing and start synthesizing, what happens over here? You don't have 3 different technologies. You got 3 aspects of the same technology, all of which have to do with symbols. If we put them together, what do we got? System. What you got is control. Because these are the 3 elements of control. Now, one of the reasons you're being walked over is some of your competitors are aware of this. They are in the control business. And they'll do communication, observation, or symbol manipulation, any goddamn thing that's necessary for control. Now, if you look at the way your service and product is used, it's almost invariably used as a part of a control system. And therefore, you leave to your consumer the necessity of synthesizing the control system. It's like, you know, how many of you, when you want to buy a hi-fi set, go out and get a Heath kit? You know, if most of you are like me, you go out and you buy a finished set. You don't want to waste your time putting together a set. That's not your interest. Well, most of your customers are really not interested in synthesizing control systems, but you're forcing them to, because they can't buy integrated controls. Now, all I'm suggesting out of this is that you begin to think of yourself as part of a larger system, and begin to think of the larger system as something which is marketable with tremendous potentialities for development. The future market, I am convinced, always lies in the larger system. I wish there were time to tell you some stories of companies that have taken this tack. I'll just mention one very briefly. In 1957, we're doing some work for General Electric in the appliance division. The average house has 23 different appliances in it, each one with a separate motor. It turned out, if you take a refrigerator, take the motor of a refrigerator, you could drive all 23 appliances in a house simultaneously. So we got curious, why the hell are there so many different appliances? The answer is simple. In the 20s, when appliances began to be developed, we were poor, capital short. So you tried to mechanize the smallest possible task so as to minimize the investment required. But by the 1950s, we were capital full. In fact, by studying retail sales of appliances, we found out that there were very few occasions, less than 10%, where a person bought only one appliance at a time. So we started to say, let's put appliances together and see what happens. We began to put them together. We found out you save about 30% when you take two appliances and put them in a single case. Well, that got interesting. So we designed a set of combined appliances. The first one was the freezer and refrigerator. After that was done, we said, well, why can't we take a whole series of appliances and put them together? And so we designed the kitchen as a manufactured unit. And General Electric came out with a manufactured kitchen. It went like mad. The market was unbelievable in the new construction industry. They built a kitchen in the factory, shifted on a truck, and it was simply dropped in place. They said, hell, that's a damn good thing. Why don't we try another room? Well, what's the next obvious room to work in? Well, it's the one where the heaviest investments are, obviously. And that's the utility room and the bathroom. So now they went to work on the utility room and the bathroom, and they came out with a design of essentially a unit that looks like this. With utilities in the middle, bath here and kitchen here, all manufactured and delivered to the site. Well, you may have seen a few months ago on the front page of the New York Times, there's a picture of a large apartment house under construction in New York with a derrick on top, and it was dropping these units in place, just piling them on top of each other, produced by General Electric. Now, General Electric said, hell, this so-called utility core is going very well. Is it possible to build a house this way? Well, the answer is no. Why not? Well, you can build a house in a factory. Many people have tried it, but it doesn't go well. Why? The transportation costs kill you. First of all, they're constrained, so on the size of the thing you can move across the road to 12 feet. And so you can do what some do. They saw the house down the middle, make it 24 feet, and then they put it together. But that's very constraining. If you try to build it at the site, you can't put a factory there. Who can afford a capital investment for a reconstruction project of a permanent factory? But there's a third possibility, a mobile factory. So General Electric went to work, and they designed a factory that could be put on wheels and move to the site and manufacture the houses on site. And this became a huge business. Now, houses are about 70% of the investment of a city. So why can't we manufacture a city? General Electric has. It has manufactured and sold 3 cities to date. Now, that's systems thinking, expansionism. Because they're performing a function for the consumer who doesn't want to be engaged in assembling the components and who wants parts which are well integrated to perform a total function. To the extent that you begin to think in increasingly large systems and stop thinking of yourself exclusively as dealing with a part, communication, to that extent, your opportunities for the future will grow. I've gone on too long, I'm sorry. Let me stop here. Do you want to take any time for questions, or I don't want to cramp what follows?
Time just for
So if there's 2 or 3 questions, 3 or 4 minutes.